NaPoly stands for Nanocrystals-in-Polymers. We have been working on nanocrystals for many years, 10, 15 years, from the perspective of light emission. At some point we started looking into polymers to actually stabilize the particles, make sure that their emissive properties are preserved over days, weeks and years. And so there we use the polymers to seal in a way these nanocrystals from ambient. The basic goal, at least the scientific goal of the NaPoly project, that is to develop a kind of generic toolbox that ensures the homogeneous dispersion of particles in polymers. You can use the polymer to improve the properties of the particles. You can also do it the other way around and use the particles to functionalize the polymer. And this dual perspective brought Flanders Make on board because they were looking for mixing magnetic nanoparticles into glues, whereby heating up using magnetic induction, a glue, a connection could be debonded in a way. Of course, if you can debond such compounds you glue together, you really improve circularity and recycling of products. Catalysti was mainly interested here in NaPoly in the use case on debonding of glues, because this fits into their research lines on circularity, on simplified, sustainable manufacturing methods.
Within NaPoly, we're mainly responsible or mainly working around the light emissive use case. On one hand, we do the characterization of the light emissive structures, and on the other hand, we are responsible for developing the demonstrators that are linked to the light emissive applications that we foresee. On one hand, we want to deposit or pattern the light emissive nanocrystals on light guides. These can be rigid light guides or flexible light guides. And on the other hand, we want to deposit or pattern again the quantum dots on lead arrays, micro lead arrays, which can be used for many new display applications for virtual and augmented reality. We collaborate together with Ligand because they make the light emissive nanocrystals and they also make the patterns of these nanocrystals. And what we then do is we characterize them in an optical manner. Are they efficient? What are the colors? What are the scattering properties? And of course, we use these nanocrystals and patterns to develop the demonstrators.
What we will do with NaPoly also goes beyond this, and we will try to reach out to any company and create awareness among any company to realize what they can do with these homogeneous dispersions of nanocrystals in polymers, because nanocrystals can have properties well beyond light emission or, for example, magnetic properties that are used in this debonding story.